Hi, I'm Phil, and today I'm going to talk about the Microbit garden. And this is my second version, and this one uses the Makecode data logger extension. So I'm going to use a mind map to describe the project, starting off at the top right and moving around, and I'll spend most of my time on the project, the last project being DLG, that's data logger version G. And my inspiration for this is to replace the Microsoft FarmBeats for Students kit, which comes from Seed Studio, using Grove electronics and a Raspberry Pi. Now, the problem with this is that it's really hard to get Raspberry Pis these days, and I'm looking for an alternative. And I'll go through what some of my other objectives are later. And I'm going to target at a price which is cheaper than the Raspberry Pi FarmBeats kit. So who will use this? It will be used mainly in STEM education, but also to teach people about smart agriculture and precision farming. So here are the projects already that I've done using the Microbit for gardening, and we'll look at the latest one. And this project, I'm going to look at the objectives, go through some of the design issues, talk about the hardware and the software, give you some results, and talk about some issues, and finally give you references. So my objective is to re-engineer FarmBeats for Students Kit using Microbit instead of a Raspberry Pi. I'm still going to collect data from standard sensors, such as from the air temperature, humidity and pressure, from the soil, temperature and moisture, and I'm also going to measure the light. The only difference is I'll be downgrading to an analog sensor rather than the digital light sensor used in the FarmBeats kit. I want to log the data both onto Excel, but also onto the Makecode data logger extension. And I'm going to use the M5 stack watering system to manage water for the soil and the plants. And I'll be looking at all the data on a 8-line OLED display, which will be attached to the Microbit. In the final project, I'll be considering how robust this is so that it can be used outdoors. And this means that it'll be put in a waterproof enclosure. It's got to be able to be maintained. And I also want to provide solar power and a battery, LiPo battery combination to power the unit. But one of the biggest aims is to be able to let STEM students build up the project from the ground up, including all the software, which is really hard to do with the Microsoft FarmBeats kit. So for software, we'll be using the Microsoft Makecode, and I'll be using a time stamp for the data logging, using a hardware real-time clock. And some of the extensions that I'll be considering are to connect it to the internet and MQTT, and also to cloud services like ThingSpeak, and consider alternative communication systems like LoRaWAN to go on to the TTN network. One of the potential extensions will be to use other Grove sensors like a pH meter. The software's got to be modular, so it'll be easy to extend and understand. And I'll be using standard sensors, and in particularly the M5 watering unit. The PC still has a role, and data can go in via data streamer to Microsoft Excel. I also want to be able to change some of the parameters like the time, date, and the set points for water and light. And I'll be using a serial port from a Arduino monitor and entering commands like these ones to make modifications. Other modifications will include enabling the pump, providing an emergency stop, and also being able to vary the polling and logging rate. I want to provide some visual clues. So unlike the Microsoft FarmBeats version, there's no display with that. Here I want to be able to give the experimenter some guidance onto what the parameters are while they're in the garden. So a small OLED display will show the air weather parameters, the soil parameters, the light value, and also the status of the pump. For the light, I'll be using a Grove relay, and for the pump, it will be using the M5 stat watering unit, which also has a soil moisture sensor on it. Also, I want to remap some of the variables to make them easier to understand, such as the soil moisture. For the user interface, there'll be some manual controls. So if you want to enable the pump, and this is a safety measure, you press button A. And to turn off the pump, just press button B. To reset the real-time clock, a combination of buttons A and B. And to clear the data log, just press the logo on Microbit. So here's an example of how I can enter a command, and here I'm using the Arduino serial monitor. And if I wanted to change the set point for light, I could enter a lower number where it turns on the light in a dim condition, and you can see that on the left. And on the right, I'm changing the polling rate to 30 seconds. For hardware, I'm using a Microbit and Grove components. Now, most of these will come from the Seed Studio collection, but the M5 Stat watering unit is also Grove compliant. So to connect the Grove devices to Microbit, I'm using BitMaker, and it has 6 sockets with some of those sockets double up in the number of ports that are available. And one of the main Grove devices is for air weather, and it will go into the I2C port. For soil temperature, I'm using the DS18B20 and probe, which is quite accurate. To turn on the light, I'll be using the Grove relay, and for the real-time clock, another Grove device. And because I'm using more than the one I2C device, I need to use a I2C hub. And for the display, I'm using a Kintronic OLED display, which goes on to the Microbit. So how's it all put together? So starting off with the PC and the Microbit, the second USB cable goes into the bit maker. So here's the bit maker connected to Microbit, and we add on to the left some of the modules. We've got the Grove light module and the soil temperature module in P0 and P1, and in P2 and P12 we link it to the M5 watering unit. And on the right we've got the Grove relay on port 16, and on the I2C port via a hub we've got the BME 280 sensor for the climate measurements, and just under that we've got the Grove real-time clock. And I'm going to add the Kintronics display, and it fits between BitMaker and Microbit, and I'll be able to see the parameters on that display. If I want to press button A, I can turn the pump on, turn the pump off with button B, and reset the real-time clock with a combination of buttons A and B, and clear the log by pressing the logo. So let's have a look at the software. And here's the complete program. And it's all done in modules using various functions. And we'll walk through some of these. So before we do the construction, we need to add the additional Makecode extensions. And you can see that there's a number of those here. On the right, we've got the temperature, soil temperature sensor using the DS18B20, the real-time clock, and on the bottom we've got the OLED display, and a very important one is the data logger, and it's important to use only version 2 of Microbit. And the last one is the BME 280. So on start, we set the program name and the station number, and we initialize the address for the BME 280 and turn it on. We call up a function to set up the log for our data logging, and we set the baud rate for our serial port at 9600. Then we're going to send the data logger not only into the Microbit flash memory, but it will also go onto the serial port. And we turn on the OLED display, and we set up some of the other parameters like the soil moisture set point, the light set point, and the polling rate for the data logger. There's nothing in the forever loop, and all the work is done in a timing function. So every 10 seconds or so, we can call the additional functions like get the data, display the data, log the data, check the water if it's near the set point, and similarly check the light if it's near its set point. So when we get the data, we're getting it from port 0 for the light measurements, port 1 for the soil temperature measurements, port 2 for the soil moisture, and we're remapping the soil moisture so it's a bit easier to understand. And the other parameters there are from the BME 280 for temperature, humidity, and pressure. And to display the data on the OLED screen, we've got a series of modules under the display data, starting off on the top line. And you'll notice that we're actually using a big size font to make it easier to see. And for logging, we set up the headers on our logging file, and all of this is going to go into flash memory. So even if we turn off the Microbit, we still have access to our data. And when we log the data, the column is set up for the various parameters. So you can see we're starting off with time, then we move on to the BME parameters, the light, soil, and finally we've got the station number. And we can change the time, that is the year, month and date, and the hours and minutes by parsing data that comes in via the serial port using this series of commands. So to get the data on the serial, we can either be a serial command or it can be a change to the time. So for parsing, here we've got the parsing commands for water, light, the rate, and the station number. Here we're checking the water with the check water function, and we'll always look at the flag called pump stop. Now, if that's set, we'll turn the pump off, which is connected to port 12. And we do something similar with light. If the light is less than the set point, we turn it on. That is, it's too dim and we need some external light. Or alternatively, if it's above the set point, we turn the light off. And for the buttons, button A and B, they're connected with controlling the pump. And for a combination of A and B, this is how we reset the real-time clock, and pressing the logo button will delete the log file. So right at the end, there'll be a live demo where you can see the Microbit garden in action. So we've been able to successfully re-engineer FarmBeats, and the data goes into both Excel and also into a file on the data logger, which is in flash memory on Microbit. We're using standard Grove sensors. Some of those are the same as in the original FarmBeats kit, and some are better. And the only one that's degraded is the light sensor. We're using the M5 stack watering unit, where it has both a pump and a soil moisture detector. And that's better than the offering from the FarmBeats kit, where you only get a relay and you have to supply your own pump. We're able to control the plant watering and the plant light, and we're able to manipulate the data in Excel, and we can even use the Microsoft FarmBeat Excel spreadsheet. So we've got a couple of alternatives available to us. And important, we can actually see the data in real time out in the garden with that small OLED display. So for STEM programming, it allows students to use Makecode and do all the programming themselves, whereas the Python programming for the FarmBeats kit is actually quite complex, and it's not likely students can go through it all in the limited time they might have available. And we can also extend it by treating our Microbit garden as an IoT device and connect it to the internet, and services like MQTT, and even cloud services like the ThingSpeak. So some of the issues, well, we don't measure the ultraviolet and infrared light that FarmBeats does. So that's the only downside. But we can extend it using other Grove devices, such as the soil and water pH can be measured. We include on our version the station number, so lots of these devices can be used. One can be a control, where you want to do control experiments. And we also conform with the FarmBeat's file protocol. So the cost of this is around about $140, which compares quite favourably to the more expensive FarmBeat's kit that includes the Raspberry Pi. And that kit's available from the Seed Studio website. But it's not available now, and it has not been available for the last 9 months. And this is one of the reasons that this alternative might be a better one for STEM students. So here's the cost breakdown. It's reasonably affordable, and you can use these components on other environmental projects. So here are some of my references. You might like to go to the Microbit data logging webpage and get some more data on how that data logger is used. Okay, so stay tuned and you'll get a live demo of the project.
This is the Microbit garden, and it's used to manage the light and the water for plants in the garden. Here I'm going to demonstrate the water management, and I'm using a pump over here, and it pumps water to another tank over here. And the pump is based on the M5 watering unit, which is a combined pump and capacitive soil moisture detector. So the Microbit is assisted with some electronics and an extra display. So on the displays, the cross means that the pump is currently off, and there's a Kitronics under the Microbit. There's a Kitronics display, and there's a bitmaker board connected to Grove ports and Grove accessories. Now, some of those include the weather module based on the BME 280, and next to that we have the light sensor, and it's measuring analog light. And when the light value exceeds a set point, it then turns on the relay. So it's just turned on the relay at the moment. Just behind that, we've got a hardware real-time clock and an I2C hub, because we're using 2 modules on the I2C port. And to show you the display in detail, we've got on the top line, DLG is data logger version 8, and it's showing the time 15:25, and just under that there's the air parameters on the left, 19 degrees C, 66% humidity, and just under that the air pressure 1010. Then we have the light. The light is 193 at the moment, and under that we've got the soil parameters. So we've got soil is 20 degrees temperature and 124. Now, so in addition to the air temperature, we've got a probe which goes into port 2 of Microbit, and that's used for the soil temperature. So to give you a demonstration, what we'll do is enable the pump. So the pump's now enabled, and we'll simulate a dry condition by taking the watering unit outside, and every 20 seconds the system polls the result. So we'll just wait until we get a new reading, and the pump should go on. So the pump is now on, and we're taking water from here and dumping that water over here. So there's an emergency control too, so if we want to turn off the pump, we just press the emergency stop, and all of those readings are being fed into a serial port, which is being picked up at the moment by the communications monitor on a Arduino monitor, and it's also going into a data logger. So we're using the Microbit data log, and it records values from the BME, the air parameters, the light parameter, at the soil parameters, and it also includes the timestamp, the station and the station number, and the set points for light and soil. And all of that can go into Excel, so we can then analyze that data in more detail. And that's it for the Microbit garden.